Hello, and thank you for joining us. Today's webinar topic is Embracing the Oils Industry with Teledyne CETAC, which is presented by Jacob Harrington, who is our Automation Product Manager. We will be taking questions at the end of the webinar, so feel free to submit those throughout using the questions function. Okay, Jacob, I'm going to turn it over to you.
All right, thank you. Welcome to this webinar. We'll be discussing the oils industry and some of our Teledyne CETAC technologies, new products in that industry. I want to thank you, first of all, for your time, for coming to join me. I do appreciate your taking the time to learn about some new products and new solutions for this marketplace. So the first thing I want to do is give a kind of bird's eye view of the oils industry and where we work in it. My almost assumption is that those of you attending the webinar will be somewhat familiar with this, but we'll go through it quickly anyway. The oils industry, in terms of laboratory practices, is kind of broken into two main markets. The first one is wear metals, and that's where we spent a lot of time, is wear metals analysis. So for large pieces of heavy machinery, you can see some examples in the pictures here. It's important to be able to maintain these pieces of equipment, and one of the ways that we do this is by taking samples of oils and coolants from these systems and analyzing those for trace elements. Now, this analysis is a trend analysis over time, so we're looking for spikes and key elements that will help direct preventative maintenance schedules, which allows the operators and owners of this equipment to know what preventative maintenance is required and do it at a convenient time. And this helps to avoid major breakdowns and also having to delay projects because of equipment malfunctions that could have been predicted. These oils analysis that we work with are all run on ICP optical systems, typically, and it's all standardized around ASTM methodology. In particular, the one that we work with the most is the ASTM D5185 method for wear metals and oils analysis. In addition to wear metals, we've also noticed an uptick in recent days of coolants analysis, which I mentioned, which is a little bit different because you're working with an aqueous matrix, but it has very similar aims to wear metals analysis, trying to do trend analysis over time to allow for informed preventative maintenance. The other side of the oils industry really is the formulation labs. These are people who are actually making the oil in some cases, and with those samples, they run on QA guidelines. They also adhere to the ASTM methodology in terms of their sample preparation analysis, but they're looking for trace metals. They're looking to track the additives that they put into their oil to ensure that proper quality is met before samples or products go out the door. All of these oil samples typically will require dilution prior to analysis. Frequently that's done with kerosene. There's also several other solvents such as hexane, V-solve, white spirit that are frequently used for diluting oil samples. And that dilution can lead to potential problems with sample homogenization. So enter the ASX 1400. Now, this is a unit that we started, it was originally released by Teledyne CETAC in 2006. It came in two sizes. So first the 1400 was released. Several months later, the ASX 1600, which is a 6-rack auto sampler, was released as well. These were designed to meet the needs of the oils industry. In particular, they have a special dual Z drive, which allows for simultaneous sampling and mixing. So while you're sampling the first sample, you're mixing the second sample. So that when you go to sample the second, it's homogeneous, and then the third is mixed, and so on. That allowed for us to be able to maintain, to improve data quality, to ensure that samples are properly mixed before analysis, and that's become a large player in the oils market. this system has been in the market for over 10 years, which means we've had the last 10 years to gain experience in the oils marketplace, to spend time in these labs, to learn about the people and learn about their problems, and to see to some extent where we could improve. So when you think of a lab, I know a lot of people think of this sort of these pictures. Personally, I got my bachelor's degree in biochemistry, so this is exactly the sort of work that I was doing with gloves and mask and a pristine white lab coat. And I very quickly learned that that was possibly not the correct tool set for the oils industry. You don't wear white if you can help it. I learned that early on doing an install on an APS 1650, which is one of our dilution systems for oils. And I think it was a single drop of crude oil onto my very nice white shirt that just absolutely ruined it. So there's a reason that we make dark blue and black lab coats. If you've ever tried to clean up a kerosene spill with chem wipes, you find they're really not the tool for the job. Paper towels work better, but again, you learn fairly quickly on that what you're really looking for is probably a drawer somewhere in the lab that has a bunch of cleaned rags that are specifically for this, and that once they're soaked up with oil, you have to put them in the right place so that they can be washed and reused. And this is actually a picture that was taken from one of our partner sites using the ASX 1400. Here the analyst is doing some work, and what I love is it kind of encapsulates everything. She's got a very dark lab coat. She's got her gloves on. You can see the oil samples there. You can also see a rag just kind of sitting at her elbow just in case. And what I want to get at is that we as a company have learned more about this industry and have adapted ourselves. And so the product I want to talk to you mainly about today has really been designed to fit that industry. As its product manager, I spent 4 years working on our service team, which gave me the opportunity to travel all over the US, North America, and also to several foreign countries. I visited oil labs in 5 foreign countries at this point, and all across the US, and I came to really love the people that I worked with there, but also it helped us to make informed decisions about what we wanted to do with our next generation auto sampler. So let me introduce the Oil 7400. The thing that honestly, the thing we get the most compliments on with this system is people love the color. And it's this nice dark gray. And if you've ever worked with oils on one of our 1400s, you know that they're only white for maybe a couple weeks. And then they start to get this dingy gray color over time. So we decided to embrace that and start with a dark gray that won't show the oil stains quite so much. There are still some white Teflon pieces, but those don't tend to stain. And the whole system was designed for working with oils. So we'll get into some of the details, and you'll see exactly what it is that we've done to try and meet the needs of this industry. First, some of the key features. It's faster, and it has much smoother movement in the XYZ. This is because it's built on the 7000 platform, which is a platform we've been using for years with some of our OEM partner accounts. But it uses better motors that allow for more precise movement, but also faster movement, that allows for the alignment to be more stable over time. And it allows you to save time up to 2 seconds per sample. That's just your XY movement, as compared to the ASX 1400. And we know that for certain applications, 2 seconds, that really adds up over the course of a day. Another key feature is the stainless steel filtered probe. So for oils, some of these applications, particulate matter can be very common, especially when running wear metals or if you're using filter paper in your samples. These particulates, if not filtered, can cause clogs in your nebulizer, in your tubing, in your junctions. And so what we've done is we've created a stainless steel filter probe. This is, I think, the 4th or 5th revision of it, that has a filter in place to remove these kind of particulates to help protect the downstream components. Stainless steel is a great material for oils because it lasts a really long time. It's easy to clean. And what you can see here, there's a little bit of a close-up of the tip of that probe. It has the latest revision of this system has a rounded tip, and the filter is actually holes that have been drilled in around the outside of the probe, which has a couple advantages. First and foremost, if there is some sort of blockage, likelihood is good that it will only be on one side of the filter. And because the filter's on the outside of the probe and not something internal, we won't be able, you can't get blockages that get caught up and in against the filter to block the entirety of the probe. This design has been in beta testing and has done very well. We recently updated it to use slightly larger filter holes, and the latest version is going to be released within the next month or so. In addition to the probe, there's its buddy, the stir paddle. So we still have the dual Z drive on the 7400 like we did on the 1400. And you can see on the right, I've got a picture of your probe and your stir going into two tubes side by side. That stir spins to prepare the next sample as the first sample is pulled up. That stir speed is configurable, and you can configure it across 3 different zones. So you can use a different speed for your standards, your samples, and your rinse station. There are aqueous and oil stir options, though primarily we found that for the aqueous applications, the stir is not necessary. The drip cup has also been improved. So it's now built on a camshaft, which has much smoother movement. As the probe drops down, it simply slides under the Z drive. And if you've ever worked on the 1400, it had a spring-loaded drip cup, which over time would kind of fill with oil, and then when the spring would hit, that cup would kind of flip out to the side and the oil could splash. With the smoother movement, we get better sample drip retention because there's less splashing, but also the drip cup itself has been improved. We've got a better inner lip on the cup that should help retain if there is any sloshing about in there. Both the drip paddle, or the drip cup, and the stir paddle are removable for easy cleaning. The stir paddle simply pulls out. The drip cup you push up on the bottom and it should pop right out. So they're both really easy to pull off and clean as needed. So why is it so important to stir our samples? There's a couple diagrams here that I think are instructive. On the left, we see one that over time, samples that are originally well mixed can kind of settle out. You'll get this buildup of particulate matter at the bottom of the tube, which can lead to false data if you're analyzing it, or lead to poor replicate data. On the right is a picture that we took just a few days ago of some gear oil samples that were diluted in kerosene, 1 to 10 dilution. And then on the left, you see one that was shaken, one that was stirred, and the third was just poured in. So we poured in the oil, poured the kerosene on top of it. All 3 of them seem like they were mixing fairly well, but you can see that, especially on the one that was poured, that the gear oil really settled out to the bottom. And the photo here is just backlit. Nothing was retouched or anything like that. So you can show that there really is a potential for problems. And even on the one that was shaken, that looks to be fairly well mixed, you can see that there's some particulate buildup there in the bottom as well. So stirring helps to maintain your samples, make sure that they're properly homogenized prior to analysis. One of the really key features for this system is our dual rinse station and peristaltic pump. So when I say dual rinse station, I don't mean that it has a spot for the stir and a spot for the probe. This rinse station was actually designed to be used with 2 different matrices. So it's a segregated rinse station. Right down the middle, there's a line. And then on one side of that line, there's holes. There's rinse wells for the probe and the stir, as well as a waste well. On the other side of that line, there's another set of holes for the probe, the stir, and the waste well. These rinse and wastes are hooked up to 2 separate peristaltic pumps on the back of the auto sampler, which allows for 2 different matrices. To switch from running oils to coolants or other aqueous samples, you simply slide the rinse station over, and then you can leave your rinse station all tubed up. You don't have to mess with the barbed fittings. You don't have to change your peri pump tubing on the back of the auto sampler. You don't have to mess with your waste containers or your rinse containers, you simply slide the rinse station over and it switches which pump is used. In addition to the pumps on the back changing automatically, there's also an LED on the front of the auto sampler that will switch between green for oils and blue for coolants. And everything is color coded that way. The rinse station on the back has the green and blue, which you can see kind of at the bottom picture there. Oils are all green, blues are all coolants, and this has also been extended to our ASXpress valves. The newest model, or the coolants valve or aqueous valves, now have a blue line. Now, I'm going to show you a video that we made that just covers how easy it really is to switch between sampling oils and sampling coolants. So here you can see the rinse station. It's mounted with a single thumb screw. So you loosen that, slide it over, tighten it back down. That's all you have to do on the rinse station. To change a sample probe, you can see we have the stainless steel sample probe here that we're taking out. And then we put in a carbon fiber probe that we typically recommend for coolants analysis. You can align the bottom of the probe to the tip of the stir paddle to give you a nice indication of where to set it, and then tighten it down, move your paddle. The LED will automatically update from green to blue, and the peristaltic pumps on the back as well will automatically switch when the rinse station is moved. And that's it. It's really interfaces features. You can slide the rinse station over, tighten your thumb screw, change your probe, and then either switch or remove your stirrer paddle. From that point on, you adjust your sample introduction on the ICP, your peri-pump tubing, and possibly your glassware. And that's dependent on the analyzer that you're using. But we've taken a lot of the pain out of switching between these matrices. And it's something that I've seen customers set up the 1400 or a 520 to try and switch between oils and aqueous. And either they're changing barbed fittings and tubing, or they're changing the whole rinse station, or they're using like a beaker as a secondary sort of rinse source for aqueous. And none of them were really good solutions. So this system was designed around this concept that if you want to run just oil on it, that's fine. You know, you kind of got a spare peri-pump on the back. If you don't use it, then you've got a backup pump should something go wrong. If you want to run, you know, your two peri-pumps as both running oils but having different types of oil, you can do that. Or you could, it doesn't have to be coolants. It could be really any aqueous, as long as it's you know, fairly low acid content. So there's a lot more flexibility there than just running oils and coolants. You can do what you want with those two pumps, but we've tried to make it very easy to work with and adjustable. Now, one of the other nice features is this spill tray. So you can see that it's black, so it won't show oil all that well. The spill tray is removable. And this spill tray here holds your base plate, the standard racks, which have been, or they're not in this picture, but you can see kind of the 4 pegs up on the top. That's where your standard racks set in. They're easily removed and wiped down. The rinse station is held in place by that thumb screw. That's easily removed. And the sample racks, of course, can lift right off. This spill tray can hold over 3 liters of liquid. And the one for the 7600, our 6-rack version of this auto sampler, can hold about 4.5 liters of liquid. Both of those are held in place by a couple pegs on the underside, so the whole spill tray lifts right out. So if you do have a spill, and spills happen, that's just the reality of it. Eventually, you know, something will get spilled, we'll knock over a tube or drop a standard vial or overflow the rinse station. And we've tried to prepare for that so that we have something that you can quickly just remove from the auto sampler, pour it into the waste, and then wipe this down, put it back on, and get back to work. One of the other nice things here, this universal base plate. So the base plate is also built here. It works with Bellart racks or our metal CETAC racks. It works with Bodan racks, or the 80-position Bodan racks. It's also natively configured for the Janus racks, so those can be just set right in. The red dots that you see in that picture are the alignment positions, so those are fixed, and there's only one alignment file. And we'll talk about a bit more in the next couple of slides. But the whole design is it's meant to be easy to use, easy to switch between racks, and easy to set up and run. To go with that ease of use, we've also improved the software. So with this ASX dashboard software, we have a number of different utilities. We have the configuration tool in the top left, that's your auto sampler config. We'll go through that in detail. I'm going to do a short overview of the others. The IQOQ has a set of tools for the auto sampler that allows you to test functionality and will give you a report. The log extractor can pull a log from the auto sampler if you're having errors that can then be sent off to service. The Express config software is our tool for the ASXpress Plus system. That's also been wrapped into the dashboard, so you kind of have everything in one place. Our firmware updater recently was updated, and it's much more procedural and easy to use. Our alignment tool has been built in here as well, and we also have CTerm, which is a simple communication protocol program. What we're trying to do is give our customers a single solution, a single piece of software that should give them all the tools they need to work with their auto sampler. So whether they want to adjust the macro on their Express, change some of the speed settings on their auto sampler, or if they're having service issues and they need to do some testing, everything's in one place. The auto sampler config, I wanted to take you through. Now, the auto sampler config has a couple cool features that aren't shown here. One is that it does an auto detect on the COM ports. When you bring it up, it'll go through and check the COM ports on the PC and find the auto sampler. The other thing is that when you connect to an auto sampler, it will pull the version information from that auto sampler, and then what it populates is the tools that you need for that auto sampler. So if you're running an ASX 560, it will be able to give you the tools for a 560. If you're running the 7400, it'll automatically recognize that and give you the tools seen here. So on the right, you have your axis speed, so you can set how fast the auto sampler moves, how fast your pumps move, and the pumps, by the way, are independent of one another. So if you want to run one pump at 75% and the other pump at 12%, that's perfectly fine. You save that to the auto sampler, that's how they'll run. And the axis speeds and the pump speeds you can test from within this program to see exactly how fast they are. The stirring speed can also be set, and they're configurable with the different regions. So if you want to have different speeds for your samples, your standards, or your rinse, you can do so. Now on the top left, we have this rack section. So this helps define the rest of the settings for the auto sampler. It makes it a lot easier to use because all you have to do is select which racks you're using, and then we automatically adjust some of our other settings like Smart Stir. So when I talk about Smart Stir, it's a feature that we've had for quite a few years in the 1400, and it essentially builds in a set or area within the firmware that if the auto sampler is sent to that area, which is the first row of the racks, of the sample racks, it will recognize that as being a Smart Stir area, and it will stir those sample positions prior to analyzing them. So essentially the stir will go in and stir, then the system goes back to the rinse station to clean off the stir, and it returns to analyze that sample, meanwhile stirring the following sample. This ensures that everything gets properly mixed. Now we've also recently added this Smart Stir feature for standards, so that if you're using the 60, 80, or Janus position racks, you can also stir your standards prior to analysis. So that will go out, stir with the stirrer paddle, and then sample with the probe. The positioning of that, so how it knows where to do Smart Stir, is based off of your rack selection. So if you're running the Janus racks, you're going to have slightly different spacing than if you were running like a 60 position Bellar rack or 60 position metal rack. Smart Stir can, by setting your rack type, the rest of the software automatically adjusts the Smart Stir features to match that rack. So it makes it really simple. You don't have to try and measure anything or go out to certain depths to figure it out yourself. There is a custom rack option available, so if you want to do something other than just one of those set options, that is also available. And one other thing is there's this right next to the rack type, it says auto stir cutoff Y. What that means is that once that we're analyzing the very last row of samples, your stir is just kind of hanging out past the end of the sample rack. With the auto stir cutoff, that tells the auto sampler once you're down to this final row, don't stir the paddle, which just helps prevent any splatter off the end of the auto sampler. So if you love the color, I know I do, but you want it to go faster, we have the ASXpress Plus for oils. Essentially, the ASXpress has been paired with the 7400. They're a match set. And this has also been set up to run oil samples for the oils market. And there are a few key things that we've changed to work with these types of samples. Before I get too deep into that, let's talk a little bit about why we want to have the ASXpress and what it is. So your traditional sample aspiration, most of the time you put your probe in your tube, and then that probe line is connected to a peristaltic pump, which pulls and then pushes the sample up into the nebulizer and goes on for analysis. That means that your sample time, your travel time from the uptake time is determined by your pump speed, your length of tubing, and that can be a good amount of time depending on the speed of your pump and the size of your pump. Then after your analysis is complete, the sampler will go to a rinse station to pull up rinse solution, which then also has to flow through the line enough time and get enough solution through to get it properly rinsed out. And that takes additional time. With a valve system like the ASXpress Plus, we use a 6-port switching valve and a vacuum pump. The vacuum pump very quickly pulls up the sample into the sample loop, which is on the 6-port valve. You can kind of see it there. There's a loop between ports 1 and 4 in the picture. Once the sample is pulled into that loop, the valve will switch, and then ports 1, which is currently connected to port 2, will become connected to port 6, and the peristaltic pump drives the loop onto the nebulizer. So essentially, it's like you have a stream of rinse solution, carrier solution coming off of your peristaltic pump, and then you insert an aliquot of sample via the sample loop into that stream, which is then carried onto the nebulizer for analysis. Because it's being delivered by a rinse solution, the loop, is rinsed out during the analysis time. And while that's all happening, the probe and the vacuum pump are cleaned out during the analysis as well on the autosampler side. We have an animation here that kind of takes you through everything. And my caveat on this animation is always that the way it loads the loop here is actually slower than the vacuum pump in reality is, but they wanted to make sure everything was clear. So here you have your carrier driving your sample in, and it's rinsing on the autosampler side. Here's the next sample that comes in. The vacuum pump pulls remaining carrier through, loads the loop. We've got carrier running to rinse out the neb in between samples, and then it switches again. You'll notice that there is no prolonged rinse period between analyses. And this is where we really get some drastic improvements for the efficiency of the ICP. This is a timing diagram, which I typically use for training customers to help them understand how the Express works. Along the bottom, you've got a lot of specific details about steps within the ASXpress macro performance and how they interact with the ICP. But I want to highlight the top line here. So what you have, the red line there is your ICP signal. And you can see that it's kind of paired to the valve state on the ASXpress. So the ASXpress, the brown is your loop, your load setting. So what happens is there's kind of an initial rinse step, then your loop is loaded. Once that loop is loaded, the valve switches, and you can see right after that, brown turns to kind of a tan color, your uptake begins. And you do get a fairly sharp uptake here because you typically only have about 6 inches of tubing or less between the valve and the nebulizer, which prevents the kind of shouldering that can happen over a long amount of tubing as the front leading edge can get kind of spread out. by keeping that tubing really short and introducing the aliquot into the carrier stream, we're able to get a fairly short shoulder on the front. And then on the back end, you can see that it drops off really fast. And this is a drawing, but it's true to life. Because the carrier solution, if you notice, there were bubbles, there were white spots kind of going through there. We introduced air bubbles into the carrier flow. What that does is it provides a barrier between your rinse solution and your sample solution so that they can't bleed together and drag out over time. It also provides this alternating surface tension, which really helps drive the contaminants out. So what you'll frequently see is you do get a very sharp drop-off in your signal intensity once your analysis is complete and the carrier starts pushing through. And you'll see that you'll even get this little blip, and that's fairly typical. It's the first 1 or 2 bubbles of rinse that come through will have a little bit of sample. You can see a bit of a blip, but it does incredible things for your washout time. And you'll notice that once that analysis completes, we immediately start the program over again. So there is no rinse time between samples. And that makes a big difference in the performance of the system. So one thing that we've been talking about a little bit here is kind of an operational efficiency idea for the ICP. Your ICP is a large investment, and you want to get your best performance out of it. So what the ASXpress does is it helps us manage how we invest our time by helping to optimize the ICP. We can reduce the time between samples by removing the rinse step, which removes the time spent rinsing. We can reduce the uptake time, and this also helps to reduce the overall solvent contact with the analyzer, allowing more samples in between your regular maintenance intervals. So here's some examples, real-world examples from the oils industry. On the left, there's a sample visual. That's for 10 minutes worth of time. So how many samples could we run in 10 minutes? The top 2 are wear metals labs, and you can see that there's with and without the ASXpress. It's easy to tell them apart because the without is the only time that you see any sort of a rinse parameter in there. So if you're looking at a line with blue, that's before the express. So at the very top there, our wear metals lab analysis, we've got originally without the express, they're running about 12 samples in 10 minutes, which is more than a sample a minute, and it's pretty good. With the express, they were able to almost double that throughput, getting 23 samples through in 10 minutes time. So in terms of operational efficiency, what we're talking about when I talk about operational efficiency, it's kind of an idealized thing here. I'm not building in warm-up times or maintenance time or that sort of downtime on your ICP. What I'm talking about is during your operational hours, whether that's 6 hours a day or whatever, what percentage of that time are you actually analyzing your samples? And what percentage of that time are you, waiting for uptake, waiting for rinse out, and so forth? Because we spend an alarming amount of our analysis, what could be analysis time, kind of waiting. So without the express, that lab that was running 12 samples in 10 minutes had an operational efficiency of only 16%. They're only spending 16% of their time analyzing. Now, they were able to get almost 600 samples in 8 hours, which was great. With the Express Plus, they had a gain of 15%. They almost doubled their operational efficiency, bumping it up to 31%, and they can run just over 1,100 samples in 8 hours' time. It's a gain of 500 samples. For Wear Metals Lab B, it was a little bit more striking. Without the Express, they were only running 7 samples across 10 minutes. With the Express, they very similar to this first lab, were able to get 22 samples in 10 minutes time. They went from an operational efficiency of 14% to an operational efficiency of 44%. That's a gain of 30%. So that a huge uptick in how much of their time was actually spent analyzing. And in terms of their samples in a day or in 8 hours, it very nearly tripled. They went from 330 samples up to 1067. This last is a formulation lab. So the previous two, they're running 2 replicates, really fast analysis, trying to crank through what samples they could. The formulation lab, they cared a lot more about their data quality. They had 3 replicates. They had a higher standard for RSDs. They also had more elements that they were analyzing as they're looking not only at trend analysis of metals, but also looking for their additive packages. So with this lab, without the Express, they weren't they were not quite getting 3 samples into 10 minutes. But their operational efficiency is 31% right off the bat. That's because they have a long analysis time, which means that they're getting, about 140 samples in 8 hours. With the Express, they're able to do just over 5 samples in 10 minutes. Their operational efficiency gained 15%, up to almost 50% of the time they would actually be analyzing. And they're up to 213 samples in 8 hours, which is a gain of 76 samples, or a little over a rack's worth. For this lab, that was huge. I mean, that's pretty much a 50% increase, and it made a big difference for them. It meant that at the end of the day, they were able to shut down their argon, shut down their ICP, and save on some of their other overhead costs, in addition to being able to get their samples through faster. So I mentioned earlier that the Express has been kind of tailored for the oils market. What I mean by that is there's a few details I want to go into. One is it's a trusted solution. So we've been running the Express or its predecessor, or the Express Plus currently. Before that, we had the ASXpress, and before that, the DSA 7. These systems, while the ASXpress Plus itself only was released in 2011, its predecessors have been working in oils labs for very nearly a decade. The software has been newly redesigned to be a little bit more intuitive to work with, easier to understand, and this flexible software really allows the user to tailor their method to their sample. So the idea with the Express is that we try to keep your analysis exactly as it was. You spend time determining your analysis, determining your pump speeds, and storing and testing to make sure that your intensity is where it needs to be, so you need to hit. With the Express, we don't touch that. We match our system to your analysis. So if your analysis with its pump speed needs a certain amount of solution to work, that's why we have our sample loops. We have quite a variety. So we match the sample loop to your application. And that allows us to tailor this whole thing in such a way that we ensure that data quality comes first. Once we make sure that we can get good data quality, then we start to crunch down and fight for every second, half a second, and so forth to get the numbers as tight as we can. Some of the other things that we've done, you can see this sample loop is actually made up of smaller ID tubing than we use on our aqueous systems. Found that for organics, using a smaller ID valve and smaller ID loops allowed us to work better with solutions that were diluted in kerosene or hexane. We didn't get as much cavitation as we would get using a larger ID. In addition to that, we use metal fittings, which hold up better in these sort of solvents over time. And we use fuel and lube Tygon tubing or superthane tubing to work with organics and, again, provide longevity to your system, because you don't want Tygon that's going to swell and cause problems. So we have, for the ASXpress Plus, we have specialized sample kits or completion kits to go with this system that match the 7000 series automation. And they work as a paired set. One example of this is a customer who's running about 300 samples a day. It's a wear metals lab, so they're doing engine oils, hydraulic oils, gear oils, and transmission fluids. They're analyzing all their samples on an ICP optical system, currently using the Oil 7400 and an ASXpress Plus, and they're running at less than 30 seconds a sample. And we were able to get to that point of 30 seconds a sample or less within just a couple days of the original installation of the system. And they're using an APS 1650 for sample preparation, doing 1 to 10 dilution in kerosene, which the nice thing about that is they're able to take their diluted samples, take the whole rack from that system, put it directly on the Oil 7400. I'm going to touch briefly on this, the APS 1650. This is a system that's been out for a long time, and it has some nice features. It's an offline dilution system for oil samples specifically. It's a standalone system. It has its own self-contained software, and it can actually share a PC with the ICP analyzer if desired. It complements the oil 7400 and 7600. They're looking at it. If you remember that 1400 from the first page, it's pretty clear that they were meant to be a match set. So this is built on the same platform as the ASX 1600. But it also works well with the 74 and the 7600s, and in the sense of they have very good rack compatibility. A few unique things about this is after it prepares a sample, it will also stir that sample to ensure that things are properly mixed before analysis. It has custom rack compatibility, so anything that you can ensure will be in the same space in a rectangular area, you can build a custom rack for. And people have done some really interesting applications with this. And lastly, it does have a level sensor option. This is only for using kind of larger bottles like are pictured here. The level sensor can actually go into the tube with the probe as it pulls up sample to measure the distance and properly adjust for bottles that don't always have the same amount. You know, sometimes you'll have customers who send you in a full bottle and somebody else only sends you seemingly 50 mils in one of these things. And it can be a pain to pour all those off, so the level sensor allows for that. In addition to that, we do have specialized pour-off racks for this that use small 2 milliliter vials. And the rack is designed such that you put the vials in and you pour in your samples, and if you over pour, it's okay. The racks are designed that any excess will go to these drip holes that are between the sample positions. Everything drips down into the bottom, which is has a little catch tray. So you go prep it on the system, and then once you're done, you dump the little cups and wipe everything down, and it's good to go. So that's all we have for the oil systems. I hope you found it enlightening and you learned something. This year in 2019, we're really working on trying to get more information out to the user base. So we have a webinar schedule. So this one is the first one, the Embracing the Oils Industry. We also have some very interesting webinars coming up regarding our MVX, the microvolume workstation, and a couple for our liquids, our nebulizer products, the U5000, the Aridus 3. Personally, I'll be doing another webinar at the end of the list in September. We'll be doing another webinar about the ASXpress Plus. It'll be a bit more of an advanced user session going into tips and tricks for maintaining optimal performance on that system. So if you're interested in any of those, please sign up so you are kept in the loop about them. Or if there's a topic you don't see on here and you'd like to know more about, please email us. You can reach out to myself or our service group. We'd love to hear from you. Speaking of which, if you need more information, please come visit me at PitCon. I'll be in booth 2517 along with a few of the other CETAC guys. We would love to have you come and talk to us. The Oil 7400 will be there on display, so you can come see it in person. You can go visit our website, TeledyneCETAC.com. There is an page dedicated to the Oil 7400 there, where we have our application notes, brochures, manuals, etc. We do have a new application note specifically for the ASTM D5185 methodology that should be going up within the next few days on that page. If you need anything from us, our sales department, you can contact cetacsales@teledyne.com. We also have an online store. You can see the link there, store.teledyneacs.com, pages CETAC. You do have to log in, but if you just need to order some parts within the U.S., you can order it online, and then you don't have to call in if you prefer to do it that way. Otherwise, our sales group is great to work with if you call or email. They're a fantastic group. Another fantastic group is our service department. I might be biased because I worked for them for 4 years, but they're a great group. Very knowledgeable, very responsive. They'll help you out. And then if you need anything, you can contact myself, Jacob Harrington. My email's on there, and I'd be happy to hear from you as well.